I'm here today with this X210 quadcopter kit. If you're watching this video to try to get a good idea of how this flies, I'll give you a little bit of that at the end. If you're here to see how this thing is put together and how to build it, that part's coming up. It's long and it's boring. Let me give you a little bit about this. This quadcopter, it has 2600 kV motors, and with 4S batteries, they get a little warm when they're flying. If you push them hard, they get pretty warm. They can get really warm, actually. If you're flying with 3S, you're still gonna have plenty of power with these 2600 kV motors, and your motors won't get nearly as hot as they do with 4S. Also, these ESCs that come with this kit are 30 amp ESCs. These are not gonna get hot at all. I've never even got them to where they've even felt warm. The motors, they've gotten pretty toasty before, but the ESCs, nothing. With this one, I'm also using an X4 RSB. It's kind of buried up in here. There's no FPV gear on this yet, and the FPV gear will come in a later video on how to add that on. Anyway, this is a pretty awesome kit. I got 4mm plates. If you're interested in watching the build video, stay tuned. If you're just here to see this, it's pretty awesome. I really like it. This is probably gonna end up being one of the racer quads that I actually use a lot in our upcoming races. In this video today, we're going to be building this kit. This is the real ACC X210 4mm plate, and it has the 2600 kV motors, and they're the Racerstar ones that I've never tried before. Also, it comes with the Racerstar BL Heli 30 amp ESCs. So it'll be kind of interesting to see how this flies compared to my other X210 frame I already have. And this one has the red motors, and it came in a package like this. Let me get this open, and we'll take a little closer look at everything that's included. So here's all the pieces that come in it. Here are these Racerstar motors. And again, I got these 2600 kV motors just because I think they're a lot cooler than the 2300s. And I can notice a big torque difference between these and the 2300 kV motors. And these also have a lot more winding up sound to them. So hopefully these Racerstar motors are about the same. Comes with the little screws here to screw it to the frame, and it also comes with the prop nut down here on the bottom. Also included are these 30 amp ESCs. If you look here, it says 30 amp, and these things are about the size of all the 20 amp ESCs that I've been flying with. And I don't know if that's really because they actually can support 30 amp or just because they put 30 amp on it. But we'll try them. And this one here comes with the little pads on the end where you solder the motor wires onto. That way you don't have to desolder any original ESC wires to solder on the other ones. Also included in this is the SP Racing F3 board. So I really like those boards. I've been using those a lot recently. Comes with 5x4x3. I think these are tri-blade props. Yep, tri-blade props, and they're the King Kong, all various colors. Yeah, the various colors I could do without, but also comes with the frame, and this one's designed to run to 5-inch, and it says 210mm, but it's really 214, and it's the 4mm main plate, which is good, especially if you're building your first racer, because 4mm plates are going to be very hard to break. Not that you can't break them, it's just going to be harder to break than something like a 3mm plate. So this is the X210 main plate, and if you feel these edges, especially these corners, you can feel they're kind of rough. So if you want to sand these down to make it have a little bit smoother feel, this is the time you want to do that. If not, then we can go ahead and move on. But if you do sand it down, make sure you're outside where you can, because you don't want to breathe this carbon fiber dust when it comes off. On this frame, if you're not going to sand anything else, one thing you do want to do is here on these holes here for the battery strap, you want to take an X210 knife and just kind of scratch off this rough corner, and you want to do it on both sides here, and you want to do it on both sides here, and then flip your frame over and do it on these other two sides here, because if you don't, these things are pretty sharp, and they're just a sharp edge, and they will cut your battery straps. And right now, go ahead and feel your frame, and you just go like this, and you can feel it really grab your thumb. And then go on the side where you just scraped it off and rub your thumb on there, and it should be a lot less friction. If it's not, go ahead and scrape off a little bit more. You could use sandpaper or anything else that can cut this down. But I'm just using an X210 knife and just kind of shaving off just enough here. I'm not trying to eat away too much carbon fiber because I don't want to lose any strength. Just enough to get rid of that rough edge. And I'm going to slide it all the way up to the top and all the way down to the bottom of this hole. And I'm going to do both of these and the other two on the other side, and the 4 over here too. So to get started with this build, make sure you have some blue thread locker. This stuff came from Harbor Freight. It was like $1 or I think it was $1 on sale. Anyway, pick up a couple bottles of these because you're going to lose them and wonder where it is, and it's going to slow down everything if you don't have it. Also, you need to have a Allen wrench that can fit the motors, the screws that go into the bottom of the motors. You also need a 2mm Allen wrench like this that will be used to put the screws that go through the frame to hold it all together. So now that I have all this stuff opened up, you have to realize that there's two different kinds of motors. There's the clockwise and the counterclockwise. And you want to make sure you put them in the correct location. And one way to tell which way it's supposed to spin is when you twist the nut on like this, it's turning to the right. So if it turns to the right, that means it's going to spin to the left. It's very confusing, but you can also see the arrows that are up on top here telling you which direction it's supposed to spin. Well, this one's going to spin to the left, and it has the red nut up on top. And so with the quad sitting here, the frame, this is the front side here. The side that has these little grooves on here, this is the back. So this thing since it's going to spin counterclockwise like this, we're going to put this one up here, and the motors that spin the same direction are going to be on opposite ends of the arms like this. So the two red ones go there, and the two black ones will go out here like this. Now when we put these on, we're going to use the screws that came with it. We're going to just put enough thread locker on it so that it gets wet, and then start putting them through. And we want to put all 4 screws into each motor. One thing to note, each motor came with 2 sets of screws, and you can see here, maybe you can kind of see there, they're different lengths. And for this one, we're going to want to use the longer one because we're using the 4mm plate. If you're using the 3mm plate version, then maybe you could use the smaller ones, but we're going to be using these longer ones. When they go through here, they should stick through about that far, and when it goes into the motor, it should be fine. It's not going up above the little base here, so you can see inside that the windings are up above the base, so we should be just fine with this one. And so you want to go ahead and get these, like I said, get these wet and then start putting them into the motors. When you're tightening these, once you kind of get to the end of the screw, you just want to give it just a little bit of push, and that's about all you need to hold these screws in there. So I got the first one done. I'm gonna go ahead and get the other 3 done, and we'll take a look what's next. So here all 4 motors are now attached. One thing worth noting is that we want these wires to come down the arm like this. And the next thing to do is we're going to zip tie, or actually I'm going to use electrical tape, and tape these ESCs down here to the arm about like this. Now the one thing you need to be aware of is that you have these holes here in the middle. These 2 holes on the back end are for spacers. These 2 holes up in the front are for spacers. And then you have these little groove holes here, and those are for the camera mount that looks like this, and it's going to slip in like this. There we go. So we need to be aware of where this is sitting, and so the wire is actually going to have to come in here between the spacer and that little hole right there. So just need to be aware of that when we start putting these ESCs on. Don't try to angle this so that it's coming right up here to this. That would not be good for the next part of this build. You can see here I put these little pieces of electrical tape on the arms, and that's because the bottom of these ESCs are showing some metal, so because you can solder them up on the top or onto the bottom depending on how you want it to. But I put that there so that way when the ESC sits on here, it won't have any kind of chance of shorting out to the frame. So I put the ESC on right here, and I used some electrical tape and just taped it into place. Then on here on the wires, you can see I cut those off pretty short, but I made them a little bit longer than what they needed to be so they can have a little bit of bend to them. That way they're not just going perfectly straight to them. So the next thing to do is to tin the 3 pads here, tin these 3 little wires, and then solder them all on. And if they're backward, it's not that big of a deal. You just need to make sure you leave a little bit of length so you can either switch them around here, or we can switch them around later in the firmware. These wires are very small, and because of that I have a pair of sutures, because using these big fingers on these little wires is pretty difficult. But using the sutures on here to grab these and move into place isn't so bad. But here I have all the ESCs in place, and some of the solder jobs, like that one looks really good. This one looks pretty good. This is the first one I did. It looks probably the worst, but they all did pretty well. That one's kind of a little bit long. That's all right though. So now that I have all the ESCs in place and they're all soldered up, the next thing to do is to get the middle plate, get the power distribution board installed so we can start cutting the power wires and start soldering those onto it. This is the included power distribution board. We need to take the included XT adapter and we're just going to slide it through the bottom side like this, and make sure you put the plus right there. You can kind of see the plus, which is the flat side. It goes over here on this side, and then we're going to solder this on to the board, and then all the ESC wires will solder onto these plus minuses around the outside. When you go to solder this on, it'd be best if you had the other piece that goes on here like this. That way when you heat these up, they don't melt the plastic and make the plastic move, or they don't shift inside there. So now with the XT60 adapter soldered in place, we're going to go ahead and we're going to tin these 4 on this side and the 4 on this side, because that's where all the ESCs are going to solder into on this board. While we're waiting for this to cool, we're going to go ahead and we're going to get out these little spacers and the little nylon nuts, and we're going to put these into the 4 center holes in here where the power distribution board is going to go. And we're going to do this taking the spacer, looks like this, and we're going to run it point down through like that, and we'll put the nut down here on the bottom. There we go. And we'll get all 4 of them put in there. Before we install the power distribution board, we want to get the battery strap put in place, and we want to get it put in place correctly. This is the front of the quadcopter and this is the back. So I took the battery strap and I ran it up through this side and down through the other side, so it looks like this. And then I also pushed this back and forth a little bit right here, and it slid up all the way into here. And the reason I did that is because it's a little thicker, because that's where it's all sewn together, and the carbon fiber may have a tendency to cut into it, so having a little bit thicker should help it not cut into it so much. And it goes over underneath all these wires down this side out to here. And so when I go to put the XT60 power distribution board on here, I'm going to put this, hang this XT60 piece down the same side as the little plastic piece for the battery strap. And the reason for that is because when this strap comes around the battery and goes like this and holds the battery on, I don't want this thing getting messed up with the XT60 piece here. So we'll see how this goes. A little change of plans here. We're going to go ahead and we're going to tin up these ports over here on the sides too. And these wires, I didn't realize this, but they would line up perfectly with this. And they'll have to go on either side of the post that goes in the middle, but they'll line up perfectly with the positive there and the negative here. And it's the same way all the way around, which is very, very nice for wiring. Somebody was thinking when they put this board together. And there, the first one is finished. I have the, like I said, here's the positive and the negative, and they line up perfectly all the way around. So they're just going to go right in here around the posts. Now again, when we get up here in the front like we are here, we have to be careful to leave enough room with this wire so we can push it back out of the way for the camera mount up here. And you know, if you're worried about it, you can just put the camera mount in place and make sure that the wire can still get past it. Here I have all 4 ESCs all connected, and we'll see how good of a job I did. I did fair. So the main thing is that they just touch their own pads and don't go across and short out on anything else. And this is going to work out real nice, having the ESCs connect to the 2 corner pads instead of the 2 pads in the back or the 2 pads in the front. The SP racing board requires 5 volts to power. And if you look at this, all these across here are all negative, and this next row right here, these are all positive. And they're all connected together. So if you short these across, positive, positive, you're not hurting anything at all. But you don't want to do that if you can help it. Also, all these are negative, so if you run power into any of these, it powers all of them. So, and also the F3 board here, it draws the power off these 5-volt rails. So what we want to do is get a little servo cable like this. And this is going to plug into the pins that we solder onto this board, and then the other side of these wires are going to go down, and we're going to solder them onto the 5-volt output on this power distribution board. On this board, the 5-volt output is right here. It says 5-volt and ground. So we're going to tin up these two solder pads here and solder that servo cable onto there. These 2 here are the ground and 12 volts. Now, if you're going to install the FPV stuff, what I would recommend is installing your camera onto these 2 here, because they're sitting behind these voltage regulators, so any spikes generated by the ESCs and the active braking won't be pushed back through there into your 12-volt camera, because these will reduce it all down to 12 volts. So like I said, the camera will go on the 12 volts, and the 5-volt, these 2 are going to be connected up to the flight board. For the servo cable, I cut this about 55 to 60 millimeters long, and I just tinned up the ends, which is not focusing. Tinned up the ends, and I'm going to go ahead and solder this on here. And I'm going to solder it on like this. That way it'll come out the side, and I'll take this. That way the wire will be long enough to bend around and plug into the pins on the flight board. So I'm all finished soldering on this board for now, and I have my voltage tester here, my connectivity tester, and I'm just going to check to see if there's any shorts in the soldering job I did. If there are, it should sound like this. Okay, so here we'll put this on the positive. I'm just going to touch all the negatives and make sure that none of them are positive is beeping, negative is not, positive beeping. Positive beeping, positive, positive, positive. Good. So I don't have any shorts inside the board here, so that's really good. All right, because we don't have any shorts, we can move on to the next part of this build. So along with the SP3 racing board, you get this little plastic case. Well, we're not going to use that for this build, but we are going to use one of the pins inside of here. And actually, we're going to use a couple of them to set this up so we're going to try to hook up the voltage regulator. So we have one more wire to solder. Not voltage regulator, sorry, the voltage monitor. And then we're going to solder on these pins. And we're going to use these corner pins. They look like this. This is going to be the most difficult part for some people. But once you get the hang of it on the first couple of them, then it's not so bad. Well, to solder this on, we're going to go ahead and just pick one of these cables. It doesn't matter which one, as long as it's one of the ones that has a lot of servo leads on it. There we go. Like this. And what we're going to do is just plug all of these onto this pin header. Then the reason for doing this is just so that when we put this on the board, we know that when we're finished soldering, that the pins, that these servo connectors will still be able to connect onto the pins without interfering on anything with the board, like the other components on the board or whatever. So I got them all plugged in. Then what I'm going to do, instead of plugging this in instead of soldering this on like this, I'm going to turn the board around and actually solder it on like this. And this isn't going to hurt anything, but it's just going to be a little different than what some people are used to. But the nice thing about this is it's going to keep all those pins inside here, all these servo leads inside in the middle instead of going to the outside. It's going to help keep all the stuff enclosed inside rather than, you know, just spread out. So the idea here is going to be to try to get these pushed in enough that you have a good row of pins like this. And we know that this is still going to fit because all these pin headers are on here. So we get it like this, and we have to just set this down well enough that we can get one of these pins soldered on this side and one soldered on this side. Once those two are soldered, even if they're not a good soldering job, if they're just enough to hold it into place, then we can solder all the other ones and then clean up the first two that we started with to get a good solid connection on all of these. Here I have the board kind of laid here, and I got 2 pins soldered on here. See if I can get a little better picture of this. And this one here got soldered on pretty decently, and then that one there. So now these pins should be in the position where I can solder on the rest of them, and these servo leads can still connect up to it. So soldering these on isn't very hard. It seems kind of hard at first, but it's not so bad. Basically, if you put the soldering iron on one of the pins and touch the other side of the pin with the solder should flow in there and make a good connection. And you just want to pull the solder off and the heat off as soon as you see it starting to flow through there. And you don't want to leave it on too long just because you don't want to heat your board up that high if you can help it. And like I said, I put the soldering tip on there, and then I kind of touch the solder to the tip and to the pin at the same time, and it usually just sucks right down in there. And it's just barely a little bit of solder on each one of these. Now, there's also these 2 pins over here that are on this end. Right here, these 2 pins, and that's for your bootloader. What I like to do is I like to go ahead and take this this piece here that is also included with the board, cut off 2 of these pins, and solder these. Why is it not focusing? There it goes. Solder these pins into those holes. That way, if you do ever have to boot load it, these 2 pins are way easier to put together than trying to put those 2 little holes together because they're near impossible. So I just use a little utility knife and I just cut these off, put this like this, and I put it on the board. Just push real hard and it cuts it off, and then we'll solder those on next. Soldering those wasn't too bad. They just slipped in there and they soldered on pretty easily. Now you just got to make sure when you solder these that they're pointing straight up, you know, or at least not bending over and touching these grounds. Because if they go over there and ground, I don't know what'll happen, but it'll definitely short those out. So yeah, that looks pretty good like that. So on this board here, up here, these 2 wires here that with this little adapter that plugs in, this is what's going to connect down to the battery to know, so that the flight board can know what the battery voltage is, so he can send telemetry data back down to your transmitter. So in this case, here's the wires, and the wires need to come down and solder on to any, really they can solder on to any port on here that we want to read the voltage off of. Well, we want to read the battery voltage, so we're going to hook it up right here to these 2 in the front, the positive and the negative right here. That way they're connecting essentially directly to the battery so that they're reading the full voltage of the battery, and then it can report, this can report it back to the Tyrannus via telemetry. So let's go ahead and get these cut on there, or soldered on there. And this, I'm going to cut this about 20 centimeters or so, just so that there's enough room I can, you know, I can mess with it if I need to, without worrying about stretching out the wire too much. So here's the quadcopter, and this is the front. Now we're going to be using S-Bus to send signals from the receiver to this flight board. So what we want to do is we just want to take this pin, the little pin adapter looks like this, and we're going to pull out all the wires except for these 3 right here. These are going to be the positive and negative. That's going to be outputting 5 volts to the receiver to power it, and then the signal wire will be used to send signals back in here. So you can either just pull these real hard, or you can use an X210 knife and lift these little plastic pieces up real lightly, and then the wires will just pull out very easily. So all the wires have been removed, like I said, except for this one. And this is the back of the quadcopter here, and this is going to slide in right into this little piece, and then we'll just snap it in place. And there we go. Now it's ready to have the receiver connected to it. Now, like I said, this didn't come with enough pieces, enough nylon pieces to mount your flight board on top of the power distribution board. So you're gonna have to find some place to get your own pieces. Well, for this, I have these little spacers, look like this. They're little nylon spacers. The shorter, the better, except for not too short, because you don't want anything from the top board shorting out to this bottom board. So I got these little spacers on here, and I'll measure these real quick. These little spacers are 5mm spacers. You can get 5mm, 6mm, probably even 7. And we're going to use these to separate the flight board from the power distribution board. So here I have all these little 5mm spacers in here, and this flight board is going to flip over and just sit right on top of those. Then I have some of these real short screws, nylon screws, that I'm going to put into the top of these, and that will hold the flight board down. Now I have all the screws in place, and they're holding this flight board down. This wire here that's going to power the flight board, I kind of like to move it over or bend it over this way a little bit so it gets out of the way. And I'll just plug it into any of these, it doesn't matter. But I'm going to put the ground on the top, because the ground pin is this top one now, and the power in the middle. And then nothing is in the bottom one there. And so this is now going to power the flight board here with 5 volts off the voltage reducer from down below. And the ESC wires will connect into these first 4 pins right here. On this quadcopter, we're going to be running the BetaFlight software, and the BetaFlight wants the motors hooked up in this order. This is motor 1, motor 2, motor 3, motor 4. So what I like to do is to go ahead and take this signal wire here, and I'll take an X210 knife or anything I have really, and I'll just put a 1 on here because this is the first ESC. Then on this one here, I'll go ahead and mark this one as 2 and the other one 3, 4. That way, if these ever come off, I don't have to trace them back to where they came from to figure out what number they're supposed to be. I just have it on the ESC itself. Now that doesn't do any good if you move it over to a new quadcopter, but I don't ever do that. I just keep all the same ESCs on the same quad and usually just replace them if they break. Now that I have them all marked, I'm going to take all of these and I'm going to bring them all up here together, and I'm just going to twist these together. And the reason I do this is to try to get a little bit cleaner look inside the quadcopter frame, and it just helps keep all the wires together and out of the way of anything else that could be on here. Another thing you could do before you solder these on, you could go in here and you could cut these wires off, or unsolder these wires, cut them down a little bit and resolder them on so the wires are actually shorter. And that is actually a really good thing to do, but it takes a little bit of planning, and then I always worry if I cut them too short. And anyway, maybe I'll do that later. But for now, I'm just going to take these, and now that I have the numbers scratched on there, I can go ahead and put them in the right order. Here a little bit closer up, you can see them. I have them all on there now, and you want to double check and make sure all your grounds are on the top and all your signal wires are on the bottom. If you don't have it connected properly and it's upside down, you'll end up having one motor that won't even spin. The little ESC will make noise, but the motor, when you test it, it won't spin. And if it does that, you come in here and double check these again, because you probably put one of them on upside down. Here I have the carbon fiber pieces laid out, and these are going to be for the camera mount, but there's no camera included in the kit, so we'll add that later. This is the top plate, and this is the battery protector that goes on the battery strap. Well, next thing we want are these 5 little spacers. And if you line these up, one of them should be just a millimeter or 2 shorter than the other one. So I found the short one. These 4 are going to be connected into the main plate, and this one is going to go between the camera mounts. So for now, we're going to go ahead and put that one aside. And we should have got a little bag of screws like this, and these are a little bit longer screws than the ones that came in this one. So we're going to take these, and these are a little bit longer so they can go through the bottom plate, because it's a 4mm plate, so you need a little bit longer screws. So it's going to go in these 4 holes out here on the edges, and screw up from the bottom and then into the spacer. On these spacers, whenever I screw from the bottom up into these spacers, I always like to use a little bit of thread locker. And so here I got the last screw in place. I'll just go ahead and put just a little bit on there so it gets wet. Then take this and screw it on there, and this should be the last one. So the bottom has the thread locker. On the top, I don't put the thread locker on because I look at the top every time I fly, so there's no real reason for me to have any thread locker up on the top. If you see any screws loose, then you'll have the opportunity to tighten them up before you fly. The next step is to go ahead and get these camera mounts put in place. Now I did have a problem where this one was not fitting over here, but I switched them around and it fit pretty well. Also at this point, we also want to get this little plate, looks like this, and it's going to go inside here between the camera mounts, if I can squeeze it in, and there it is. So that one fit in there just perfectly. On my other quad frame, it did not fit in there at all. So now with this, I'll put this put together, we're going to put this into the quad frame like this, and we just got to be real careful down here at the bottom down here not to pinch these ESC wires, and if they're in the way, hopefully you left enough room to push them back out of the way. If we didn't, then you'll have to take it apart and unsolder the wires and move them out of the way, and then put it all back together. Hopefully you don't have to do that. Here I have all the screws in place and the extra little mounts up here to help hold the video transmitter in place. Now, like I said, this is the extra short spacer that came with this kit, and it needs to fit inside between these plates like that, and then we'll put a couple of these short screws in from the sides. Now, if you're running a GoPro, the idea is that you'll run the battery strap down through this little slot here, up around this little spacer, and then up around the GoPro, and if you tighten it up tight enough, this should be enough to hold it in place, and you'll have a pretty good angle on the camera. All the carbon fiber pieces are in place now except for the battery protector. So for the battery protector, we just want to pull this all the way off, and we're going to run it up and down through the strap like that. And then it'll have to have a little bit more adjusting based on what size of battery you're running, but just to get it in place, and then slide it through and lock it in place. And this is where I was talking about, it's kind of nice not to have to fight with this battery connector with the end of your battery strap. The next thing to do is to get a mini USB port. The next thing to do is get a mini USB cable, and we're going to plug it into here and connect it to the computer and do some tuning on the flyboard so that it's ready to fly. So now with the quad this far along, the next thing to do is to attach the receiver. And for this project, I'm going to be using this X4R SB. It looks like this. It's called a naked one because it doesn't come with any pins, the naked X4R SB. So the first thing I need to do is go ahead and cut these wires off. Since there's no pins, I'm not going to be using the pins, so I'm going to go ahead and cut this off about a thumb's width here. Maybe a little bit more. There we go. And I'm going to solder these wires directly to the receiver back here to these pins back here on the left, those bottom three right there that have a little bit of solder on them already. So let me get that done and we'll see how it looks. I have those in place. I'm going to go ahead and do the connectivity test here and make sure that I didn't short any of them together. They're kind of small and hard to see, so we'll check them real quick. And check. Yep, okay. So if I touch these two, nothing, 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 good. If I touch the two grounds together, yeah, those are short. Okay, good. So they're not shorting at all. Perfect. To make this next part a little easier on yourself, it might be better if we were to move these wires down here between these boards, so that way they're not up here taking up all this room, because that is right where this receiver is going to go. So I'm going to point the two antennas in here and then try to pull the receiver in, and then we'll mount the antennas up to the side to a couple of zip ties to help pull them up out of the propellers. Here I have two zip ties in place. I just ran them through the carbon fiber piece like that. And now these antennas will just use some electrical tape and tape these up to the zip ties, and that'll help keep them up out of the way. Down here on the receiver, I took a little piece of foam tape and put it inside here and squished it up to the top plate. And then I used the big zip tie to wrap around to help hold it up to the top plate so it wouldn't have any tendency to come off. And that foam tape should not only help hold it on, but also keep it from sliding out the back. So let me get these taped on here, and we should be able to start doing some programming. There we go. Those look pretty decent. Push them down a little bit. Ideally, these would be 90 degrees apart from each other, but that's probably good enough. All you're really trying to do is keep them at a good angle so that way you always get a connection to back to your transmitter. So now we got this thing finished building, the next thing to do is to hook up to the computer and start doing some programming. So here I have the mini USB connected up to my laptop. We're going to go ahead and plug this in, and hopefully this should light up. Oh yes, good. And I have BetaFlight running here, and BetaFlight found that it is not running BetaFlight software. Okay, that's all right. We don't care about that. Go ahead and hit that. Disconnect. We're going to go to firmware flasher. We're going to choose the SP Racing. Where is it? A Racing F3, and we're going to choose the firmware. We're going to put the 3.0 on it. So when we come down here, we got to click on load firmware, and there it downloaded it. So now we want to click flash firmware, and hopefully it starts flashing. Flashing. Okay, it timed out. Great. All right, let's try this again. Up here, we have to So here I have the jumper put on the last two pins that I soldered on, and they're bent over a little bit, but that just made it a little bit easier to get it on. Okay, so now I have the no reboot sequence checked on, and I have the flash on connect checked. I'm gonna go ahead and try to plug this in, and we'll see. It should do it automatically, right? No? Okay, click on flash firmware down here at the bottom. Oh, it's already flashing. Look at that. Oh, thank goodness. Sometimes I always get a little worried when I have problems flashing it, but it usually ends up working as long as you're doing it correctly. All right, programming successful. So that is very good. Okay, I'm gonna go ahead and unplug the board. Okay, jumper's off. Let's try it again. Plug it in and connecting. Look at that. There it is. Thank goodness it works. Assuming you're using the X4 RSB, there's only a few things we need to change in here. First thing we'll do, we'll come up here and click on ports. And we're going to click on the serial RX on UART3, hit save and reboot down in the corner, and we should see the status ready up here again. And we're going to click on configuration, and down here in the yaw degrees, this is where we're going to tell it that we rotated the board. So I'm going to put in here minus 90, and I'm going to go ahead and hit save and reboot. And again, the status up here says ready. The next thing to do is to scroll down a little bit. If I can do it, come on, there we go. And on here, on this receiver mode, we want to click on RX serial, and then down here in this next box, we want to click on S bus, and then hit save and reboot. And that should be all we need on this page. So if we come over here to the receiver tab, this is where you're gonna have to plug in your battery and make sure that your receiver works. But if you're gonna do this, make sure your propellers are not on, because you don't want the thing spinning up and flying all over your room. So I went ahead and I connected the battery to the quadcopter while it's still connected to all this, no big deal. And nothing smoked, so that's good. I turned on my receiver, and if I put the throttle up, I can see the throttle goes all the way up to 1996, and it comes down to about 997, that's good. And the roll is correct, good, and the pitch looks good. And the yaw was correct too. Okay, good. So all the controls are correct. Now you can see down here, the quad is still spinning a little bit like this. And that's probably because some of your trims aren't centered. So you kind of have to figure out which one it is. In this case, it looks like it's a little bit of my ailerons. They're just kind of pitching back the other way now. And a little bit on the elevator. You just got to keep playing with it until it stops moving. And there. That's not bad. So here now you can see that I have all my sticks are just sitting here, and it's just sitting near perfectly still. That means I got all my trims correct. So, and if you're using a Taranis, this should all be default. But up here I'm using it for Taranis, it's AETR 1, 2, 3, 4. If you're using a different transmitter, you might have to change the order of these. This is aileron, elevator, throttle, and rudder. and which channels they're associated with. And you can change either the letters or the numbers to change it. And also, let's see, I think that's all there is on this page. But now we know the receiver is set up correctly, so we should be good with this one. So if we go over to the PID tuning tab, this is where I'm not going to change any of the defaults. We're just going to leave them all just like they are, because this quadcopter in particular should be tuned pretty well for these settings. One more thing, back over here on the receiver tab, we want to make sure that one of our switches changes the auxiliary 1. Like right here I'm flipping the switch, it's a 3-way, and this is the one I'm going to use for the angle mode so that I can go back into self-leveling if I need to. So over here I'm going to click on modes, and in here I'm going to put on horizon. So I'm going to say add range. I'm going to put it on auxiliary 1 because that's the one that was moving around, and then if it's in this middle range, then it will be on. And right now there's a little bit of a orange mark sitting right here. And if I switch the angle mode, if I switch it, then the yellow mark moves up here, indicating that it's inside these parameters. So if I put it to the middle of the switch, it'll go there. There's also angle mode. I'll go ahead and turn this one on, but I'm going to slide this one over to the far right. So that way when I put it into the 3rd position, if I flip the switch again, it moves over here to this mark here. So now it will be in angle mode. And then again, both of these are on auxiliary 1. And then the last thing you need to do is hit the save button down in the corner, and it saves it. And it should say EEPROM saved up here, which it does. The last thing we need to check are the motors and make sure that they're spinning in the correct directions. So we go ahead and we click on the motors tab, and this is where I said you want to make sure you have your props off. We'll go ahead and we'll click on this to tell it, yes, we understand there's problems if you have your motors on. So what we're going to do is we're going to slide these up one at a time, and up here it shows you the way that the motor should be spinning. The back one should be spinning clockwise, and then counterclockwise, and clockwise. There we go. So, and they should also be spinning in that order. If you test these and they're not, and the wrong motor is spinning, then you need to make sure you just have your servo wire plugged into the correct position on your quadcopter. So what I'll do is, since I have it armed now, I'm going to go ahead and click on this. I'm going to drag it up, and I can see this. I can see the one motor is spinning, and it's actually spinning the correct direction. So that's good. I'll go on to the next one, check it, and that one's actually spinning backward. And then I'll go to the next one, and that one is spinning backward, and this one is spinning correctly. Okay, so that's good. I only have 2 motors that are on backward, but that's to be expected since I wired up all the wires the same way. So the next thing we're going to do here real quick while we're in here is calibrate our ESCs, and you can do that by turning off the arming thing, unplug your battery from your quadcopter, and then we're going to click on this again, and we're going to grab this master and we're going to crank it up all the way. And it should be fine because you have your battery unplugged. So at this point, we're going to plug the battery back in, and we should hear a series of beeps. So then I'm going to click on this. I'm going to push the end button. And the end button just brings the little slider here all the way back down. So now at this point the ESCs are calibrated. So I'm going to go ahead and unplug the battery. Alright, so the ESCs are good. The only thing we're going to do now is actually upgrade the firmware on the ESCs. So we'll probably have to do this again after we're finished. So I'm going to come out here to this MediaFire website, and I'm going to download the latest version of BL Heli. And BL Heli will allow us to flash the firmware on our ESCs. I'll have links to this in the description. So here I have all the files extracted, and here's the BL Heli executable. I'm going to go ahead and double click on that, click run, let it start up. Okay, so now at this point I'm going to go ahead and plug the quadcopter back in. I still don't have any props on it. Plug the quadcopter back in. So now all the ESCs are powered up. I'm going to come up here to select Atmel Scilab's interface, and I'm going to click on Scilab's BL Heli bootloader clean flight, and then I'm going to come down here to the bottom, change the COM port, and then click connect. And there it got connected, it says. So I'm gonna go ahead and click on read setup. And it read all 4 of them. And these are all running version 16.2 of the BetaFlight software. So what version do we have on here? Okay, so they're all running 16.2. Wow, that's actually really new. Okay, that's successfully. Okay, here you can see it says 16.2, and we're going to put the latest one on. So I'm going to click on Flash BL Heli, and it should already have it. It does. It says 16.3. So go ahead and push OK. Yes, flash it on. There's flashing it to the first ESC, and hopefully it'll do all of them. And this is actually flashing through the flight board, so I don't have to actually connect the computer to each individual ESC at the same time. Alright, so here's the next one. Go ahead and push OK, OK. Okay, so now that they're all upgraded, we can see they all say 16.3. This one says master, and the other 3 say slave, so that's good. If they don't say that, you'll probably come down here to check and run and click on that and run through some processes to get them set up in order. But it looks like they're okay. Now we do know that from the testing we did that the motors 2 and 3 were backwards. I'm gonna go ahead and make it so ESC2 is the only one that's checked. I'm gonna do read setup. It reads it and it says it's reversed. Okay, so that's good because that's the one that was backward. And now I have ESC3 checked, and I'm going to reverse the motor direction on it and push right setup, right OK. All right, so if I check that, uncheck that one, I'm going to check on 4, read setup. And 4 says normal. Oops. 4 says normal, so that's good. And let's check on 1 real quick. Read setup. And 1 says normal. So we should be good to go for the directional, which way the motors are spinning. The last thing I want to do is I want to turn on the brake on stop. When I turn the throttle off, I want it to stop the ESC. So I go ahead and click on, change it to on, and then hit right setup. And that took care of 1. Now we'll read setup. Change that one to on, right setup, okay. I wonder if I can click on 2 of these at the same time. What do you think? We'll try it. Right setup. Okay. Did it reverse the motors? I hope not. Nope, should be good. So now all the ESCs have all been updated to the latest firmware, and they all have the programming on that we want them to. So we'll go ahead and we'll exit out of this. Actually, we'll disconnect from the COM port. Never heard all the motors spin up again, or arm again. So let's go back over to BetaFlight, and we'll do connect, and we'll go to the motors, and we're going to check the direction on the motors and make sure they're all spinning the right way now. So again, I click on this so the motors can spin. And then I click on this one to spin the first one, and the motor's spinning the correct direction. This one is now spinning the correct direction. This one's spinning the right direction, and so is that one. Thank goodness. Okay, good. So they're all spinning the right direction. Now, next thing I want to check here real quick is see when do the motors all actually start spinning up. So I'm going to click on this master, and I'm going to start pushing the up arrow, and you can see these numbers here are going up. And I'm going to try to find where all the motors actually start spinning smoothly. Holy cow, they're already spinning. About 35 looks good. They're not spinning too fast. Here they're spinning pretty smooth. So that's about what I want the minimum throttle to be. So we have this set about 135. So I'm going to go ahead and turn the master back off, disarm the motors, and I said 135 here. So I'm going to go back to configuration, and over here I'm going to change the minimum throttle down to 135. So I'll go ahead and just type that in, save and reboot. That way, when I turn the throttle on, it'll go to 1035, which is just the motors spinning very smoothly. So now with all the programming done, hopefully this will fly. I want to put some propellers on it and we'll take it outside. So here I pulled the 2 black props and the 2 red props out of the packages because I'm going to put the red on the front and the black ones on the back. So when you're looking at this quadcopter and it's facing forward, the 2 front propellers are going to spin and turn into the middle. So we want to take the 2 red props, I'm going to put the red props on the front, and we want these to spin into the middle. So they spin this direction with they spin to the top side first. That's what gives it the lift. So that one goes over here and this one goes on this side. So when it gets on there, it should spin into the middle like this. So I got the prop nut here. I'm going to go ahead and put this back on. And this one should be tightening to the left. If it's tightening to the right, you got your motors backward. And the reason that you want these to be directional is because if the propeller hits something, you want it to actually try to tighten the nut instead of loosening it. Because if it loosens it, the nut will go flying off and you'll never find it again. So this one over here is on. So I'll tighten these up in just a minute. But again, like I said, these need to spin so they turn into the middle like this, into the middle. And on the back side, they're going to also turn into the middle. They're going to spin this direction. The front ones spin this direction, the back ones spin this direction. One main reason that you would want to use different colored props between the front and the back is for line of sight flying. And since this doesn't have any FPV stuff in it, the front propellers being red will help me remember that the red is in the front and the black is in the back. So like I said, I'm going to use this little tool here and tighten these lock nuts up, and then I'm going to tighten them up as tight as I can without destroying my hand. But really this need to be tight enough so that they grab the propellers and keep them from spinning around. And the first time you put these on, it's going to be kind of tight because it's cutting those initial grooves into that lock nut, and it gets kind of tight sometimes, but just keep turning, it'll stop eventually. There it goes. So that one's on pretty tight, and now it's got to do the other 3. There we go. All ready to go try to fly it. Hopefully it works and it doesn't crash and roll over. It shouldn't, because we made sure all the settings were correct and that the flyboard actually turned the way that the real quad was turning when we had it plugged into BetaFlight. And also you can see here how this strap comes over here away from the little plug here, so you're not fighting with it anymore when you try to plug in. And the battery wire will just come around and bend and plug in. Alright, so here we go with the first takeoff. I got it in the grass just in case something goes crazy, but I don't think it will. I'm going to go ahead and arm the motors, and we should see those motors spin up to what we set the minimum throttle to. Yeah, see, they're just sitting there spinning nice and smooth. So I'll go ahead and I'm going to put the throttle up about halfway and get it up off the ground. There we go. And look at that, it's already flying well. There's forward and coming back at us. And this is with the default BetaFlight tuning. And so the left and right's working pretty well. Let me go ahead and flip the auto level on, we'll see what happens. Okay, so now it's in angle mode. And now when I let go of the sticks, it's trying to level itself back out. Let me see if I can get a little closer. I let go of the sticks, I'm tapping forward and tapping back, and it's trying to auto level itself back out. And that's really good if you're just trying to learn, but in the long run, you really want to get good at flipping that auto level off and on a lot. So I'll go ahead and I'll put it in the second position of the auto level. And again, it's doing the same thing. The difference is if you go to the first position, it won't actually roll over. It'll maintain itself and not let you flip it over. If you go to the second one and you roll it all the way, then it will go ahead and roll over and do flips and rolls and things like that. But I'm gonna go ahead and turn it back off. There, it's back off now, just by flipping the switch. And the sticks seem to be pretty good for racing. Now, if you are going to be doing some freestyle and that kind of thing, you might want to have your sticks a little bit more sensitive, and you can change your rates on that if you want. But this seems to be doing pretty well. And this is running on a 3-cell right now. I normally run these on a 4-cell, but I didn't have one charged, so I'm doing 3-cell. I'll try to go out here a little bit further, and we'll do a roll. And that's with the roll cranked all the way over to the side. Let me see if we can get closer. I'm going to do some flips. I'm going to crank it all the way to the side so you'll see how fast the rates are
by default. Man, that thing is riding smooth. So that was a full tilt flip, or full tilt roll, I guess. We'll roll to the left this time. I'll try to get a little closer so we can see it a little better. Here we go. We'll try another roll. These are just little 1 foot rolls. Well, a little bit better than 1 foot, but I'm doing it over concrete, so I'm a little bit worried. But it's doing all right. Here, we'll do a little burnout here real quick to see how well it does. Holy cow, I can feel those motors blowing tons of air. Here we go. I wish that car wasn't parked out here. I feel a little better about it. Maybe we'll get out to the flying field and fly this a little bit on 4S and really see how it goes. And again, this is just running on 3-cell, and it's doing spectacular. If you're also, by setting the min throttle, if you actually cut the throttles off all the way, those motors keep spinning just enough that you still have control. And if you find that you don't have enough control with the throttle turned all the way off, you can go back into BetaFlight and increase that min throttle by about 5 or 10, depending on how much you think you need, and try it again and see if it works any better. But this seems to be working pretty well for me. It probably wouldn't hurt to have it a little bit higher. But if you set it too high, and as soon as you arm your motors, they're going to start spinning at that min throttle rate. And if it's too high, it'll actually lift the quad up off the ground, and you'll be chasing it out of the sky like I did when I was trying to figure out what min throttle really meant. All right, we'll try another backflip here. We'll try a front flip, see how it does. It does front flips real easy. Backflips, they're easy. Now you got to remember that we don't have any telemetry on this yet. So you want to make sure you're timing your flights. You should be getting about 3 easy minutes out of any 1300 or 1500 battery. So this is the X210 kit with the Racerstar motors and Racerstar ESCs. And if I feel the motors right now, after pulling it out of the air, they're like on the warm side, but they're definitely not hot. The ESCs, I can't even feel anything coming off of them. So we'll take us out to the flying field and get a little bit better feel of how much it can really get up and go. So I'm out here at the flying field with this X210 from Real ACC, and we're gonna do some LOS flying now. Hopefully this goes well. Hopefully I don't crash it. I don't have any FPV gear on here because it doesn't come in the kit yet, and but I'll be getting a kit later to put on here, and I'm sure this will be awesome. Here we go. This is running on 4-cell now. The other day I was running on 3-cell, so I'm kind of anxious to see how this does. Here we go. Little burnout here right at the beginning. Holy mackerel, it's fast. And it rolls pretty easy. It does backflips easy, front flips, left flip. And again, with this, I'm just using the default BetaFlight tuning. I'm not doing anything special other than, you know, rotating the board and just a couple other things for the S-Bus. But other than that, it's pretty much stock. It's running the BetaFlight 3.0, which I'm really impressed with so far.
1 minute.
Okay, just as a warning, I don't recommend catching it out of the air. I'm gonna go ahead and feel these motors. They're a little warm for 4S. They're not probably too hot. ESCs, they're 0. They're zilch. These are a little warm, but then again, I was pushing it kind of hard on purpose, trying to make them warm. But anyway, this is the X210 Real ACC quadcopter kit, and I hope you enjoyed the build video. I'm gonna be adding FPV stuff to this later. Get subscribed up, and if you have any questions, leave in the comments, and as always, thanks for watching.